A very good evening to all of you from Kuwait. My name is Riaz Jamaldeen, and I'm the Vice President of the Chartered Accountants of Sri Lanka, Kuwait chapter. A very warm welcome to all of you to this program, Thinking Like a Data Scientist. As you're aware, this program will be based on two sessions. One is today, and the next one will be on 1st of October at 4 p.m. Kuwait time. So please be a part of that as well to gain the full advantage of the program. You can use the Q&A tool to ask your questions, and our presenter will be answering your questions. We are very glad to see over 380 registered participants for this event. So it's a very welcoming program, we could say. So the presenter for the day is Mr. Thisara Watawana. Mr. Thisara has over 8 years of experience in data science and data engineering across various industries, and he is currently working as the managing director at Boffin Institute of Data Science. And he has earned his master's degree in computer science from University of Colombo and his bachelor's from University of Moratuwa. And Mr. Thisara is a senior data scientist certified by the Data Science Council of America, which is called the DASCA, and holds a Professional Graduate Diploma in IT awarded by the British Computer Society. We are all glad to have Mr. Thisara here for the program, for the webinar today. And let's get into the program. Over to Mr. Thisara.
Thanks, Riaz. Good evening and welcome all of you to the first session of Thinking Like a Data Scientist. I hope I'm audible enough for everyone. And if you can't hear me clearly, or if there's any problem in the communication, just you can type it in the message box. Okay. So, and let's start with today's session. So, as you are aware, we have two sessions planned. So the first session, today's session, I'm going to take you through some of the fundamental concepts of data science and big data from a business professional's point of view, right? So this is not a technical presentation, right? I'm not going to address technical topics or technical details of big data and data science. Rather, this is kind of, I have included some of the fundamental concepts which required for you to understand what big data is or what data science is and how you can utilize these concepts and utilize these tools to get a maximum value in your business organization. Okay, so first session, I'm going to take you through some of the exercises with the fundamental concepts. And the second session, which we have planned for next Saturday, which will cover a comprehensive case study, how you can pick one problem or one problem domain in data science, and as a finance professional, as a business professional, how you can take your thinking process, the thought process, how you can arrange it to get the maximum benefit out of big data and data science, right? Okay, so let's start with our concepts. Okay, so this is the question that everybody wants to know, right? What is big data and data science? Okay, but now this is the problem, right? It's filled up with all the technical jargons. There are a lot of concepts that we need to cover, from fundamental definitions of data science and what big data is, what are technological approaches or technological aspects of big data and data science, what you need to know in order to become a data scientist or a big data analyst, right? So there are a lot of confusions, a lot of concepts are roaming around, okay? Uh, so let's forget this typical question of trying to define what data science and what big data is, right? So, because then you have to go back 20, 30 years down the memory line, and then we have to start with 3Vs. What are the 3Vs? Probably some of you have already heard of 3Vs, the volume, velocity, variety. Then 3Vs became 5Vs, 5Vs became now 7Vs, right? So we can discuss about these definitions, what big data is, what data science is for, for separate 2-3 sessions, okay? So for business professionals, this is not required. My personal view is that this is right now what we are working on. So let's forget about the question what, okay? Because there are a lot of confusions, definitions, and things that you need to cover in order to answer this question, right? Instead, let's ask the right question: why we need data science and why we need big data, okay? So that is the question you should be asking right now, okay? Rather thinking data science as a technical knowledge area, we'll try to map it into the business context, okay? So as finance professionals, as accountants, as business professionals, I think that's what you need to understand before doing anything else, right? So why you need big data, right? Why do you need to incorporate big data and data science in your organization, right? Why you have to do that? So we came up with a very interesting definition to answer the question why rather than what. So instead of talking about 3Vs, 4Vs, and 5Vs and 7Vs, let's call this concept 4Ms of big data, right? So what are these 4Ms of big data? It's very simple. I'm sure all of you will understand it very clearly because you all are working with numbers, working with rupees and cents, working with dollars maybe, right? So simply think big data and data science as a tool for you to make more money, right? So this definition is very interesting, and it's very easy to convince people in the business or the corporate world when you start talking about money, right? So let's stick to this interesting definition of make me more money, 4Ms of big data, right? So let's forget about what big data or what data science. Rather, we'll start with why we need big data, okay? So I hope all of you are now eagerly waiting to see how you can make more money using big data and data science, right? Let me give you some real world examples, okay? Netflix, I'm sure all of you are, familiar with Netflix and probably are customers, most of you. So now how Netflix makes more money using big data and data science, right? In annual basis, right? In an year, they have managed to save roughly $1 billion US. They're a big company, but still $1 billion US, right? per year. Okay. By incorporating big data and data science in their customer retention program. Okay. Of course, Netflix is a data company, or you can consider Netflix as a tech company. But still, this is one use case, one business case where they have used big data and data science to save their customer churn, or the cost they incur by losing customers, right? So they have managed to retain customers and thereby cut down their cost by $1 billion US, right? Interesting example, right? Okay, let's look at another one, right? So you all probably know about Walmart, right? A leader in the retail industry. So now they are heavily into the e-commerce arena. So they have their online platforms. Now through their online platforms, they collect a lot of data about their customer patterns, buying behaviors, their user behaviors, different product combinations that they buy. So by incorporating data science and big data in their online sales, in e-commerce platform, they have managed to increase their sales by $1 billion US. That is a 10 to 15% increase in their online sales, right? $1 billion US. That is by incorporating big data and data science related to their customer behavior and customer purchasing patterns into their sales strategy. Okay, right. So we'll look at another one. So the Danske Bank, which is the largest bank in Denmark, right? They have achieved 60% reduction in false positives, right, in their fraud detection. So false positives always lose money for you, right? Okay, so especially in risk analysis, especially in the banking industry, customer risk analysis, fraud detection. So the idea is minimize the false detection as much as possible. Now, using big data and data science, they have managed to reduce it by 60%, thereby increase operating profit in 70 million US dollars. This is in 2018, right? So you can see there are very interesting, all these definitions suddenly become very interesting when you connect this with money, right? So now we know why we need to incorporate big data and data science. Simply, we want to make more money. So how we can do that, right? So we forget about the question what. Now we looked at why, and then we need to look at how, right? If you want to make more money using data science, as accountants, as financial professionals, you have the best view of the company in terms of numbers, right? By profession, I'm not an accountant. I'm not a financial professional, but I work with financial professionals and accountants for more than 8 years, right? So, and I know you have the best view of the company in terms of numbers, right? Simply, you are the ones who are preparing, processing, and analyzing all the financial data, which represent a larger portion of data gathered and processed inside any business organization, right? So when you have that kind of a view, right, it's very easy for you to find a place to start, right? So my recommendation, my advice for all of you is look at your financial statements, right? And in financial statements, you can identify a lot of areas where you can make more money by incorporating data science and big data, right? So how we incorporate, we'll come to that. And we have a complete case study to cover all that, right? But simply, I'll just list down some of the areas by looking at a financial statement that you can think of. For an example, your revenue, okay? So basically, you ask the question how you can increase your sales, how you can increase your number of customers, right? Then maybe how you can, let's say it's a retail outlet, how you can increase your customer footfall, right? These are some of the few business cases that you can use, right? Okay, which will increase your revenue. And then you can look at cross-selling and upselling, how you can sell more, right, for your existing customers, right? Then customer retention, like what Netflix did, right? Then when it comes to the cost, when it comes to sourcing or procurement, how we can rationalize your suppliers, right? Then how you can do your production planning and scheduling better in order to cut down your cost. Then how you can optimize your manufacturing resources, okay? And then when it comes to inventory and supply chain, how you can improve your sales and operations planning, right? SKU rationalization, inventory optimization, right? And as finance managers and accountants, debt collection process, asset utilization, cash flow forecasting, distribution rationalization in terms of the sales and distribution function, asset and liability management, interest rate risk and forex risk management, right? Real estate valuation and market trends, depreciation and amortization predictions, right? So these are some of the areas that you can create use cases or business cases for your organization, right? This is where you need to start. Now, a lot of people, there are a lot of misinterpretations when it comes to data science and big data. I'll explain some of the key myths about data science in the latter part of my presentation. But a lot of people tend to think, I have that personal experience, even the top management, when we go to a company, the finance professionals or rather the top management, they think this is kind of an IT experiment, right? So the first people they call when they want to start a data science or a big data initiative is your IT team, which is not the correct process, which is not the correct way to do it, right? You have to start with your business initiative. It has to be business driven, right? So as accountants and finance managers, your financial statements will give you the best view and the best place to start this business initiative, right? So I'm sure most of these listed use cases already you are doing it, right? Cash flow forecasting is something that you're already doing. Debt collection is something that you're already doing. But what happens is using big data and data science, you can optimize this process, okay? Either it could be a revenue increment by increasing the sales, or it could be a cost saving exercise by cutting down operating cost, cutting down your inventory, cutting down your sales and distribution cost. And it could be some operational excellence program, right? for an example, you're optimizing the debt collection process, right? Or else you are doing a distributor rationalization process, right? So for all these use cases, you can incorporate the big data and data science, right? So don't try to start with your IT team. Don't try to, start with some technological, uh, sort of a technological, new technological implementation or, something fancy. You can start with what you are already familiar with. You are pretty much comfortable with your financial statements. So start from there, right? So now let's do I hope you got the picture, what I'm explaining, right? So just I want you to imagine, or I want you to think of your organization, right? Now we have listed so many initiatives which we could, start with, right? But let's do a simple polling exercise, right? It's an online poll I have created. So what I will do is I will share this link in the chat box. Right? So then everybody can answer, or else you can simply, if you have logged in using your mobile, just or any other device, you can scan that QR code as well, right? So go to this online poll, and I want you to think any initiative that you are familiar with as business professionals, as finance professionals. I want you to think. Now we discussed some of the use cases, but let's try to categorize it or cluster it for 4 high-level categories. Okay, all the use cases. So first category, increased revenue through customer, market, product expansion. Right. So you're thinking about sales right now. Right. You're planning to increase the number of customers, or you increase your revenue. Or else you are trying to cut down your cost, especially a period like this. Probably you are thinking of cutting down your operating cost, right? Or sales and distribution, or even transportation cost, right? So that's number 2. Number 3 is cost saving through some risk minimization, right? It could be customer risk analysis or the supply chain resilience. So you're thinking how you can mitigate the risk factor, and thereby how you can reduce that cost, right? And the last one is cash and treasury management. So you are thinking something related to your cash flow, maybe how you can improve your cash flow forecasting accuracy, or maybe how you can optimize your treasury function, right? Managing cash, debt collection, things like that. So I'm not a finance professional, but if I'm saying something technically incorrect, just let me know, right? But I'm just trying to summarize it under 4 different high-level categories, right? All what we discussed. Okay, so few of have already voted, so I encourage everybody to participate, so then I can get some idea about my audience as well. So what you think, right? So maybe I can customize some of my deliverables based on that. So far, the majority is thinking of increasing sales, increasing revenue, right? Okay, I can see some responses coming in the chat box also. Better if you can, vote in the online poll, then it will be easy and everybody can see it. So I'll give you another minute maximum. I can see the majority is, looking to increase their sales. That's good. That means that they directly want to make more money, right? Which is good. All right, 58 have voted. Okay, interesting. Which means we have more, sales-oriented professionals here, which is good. Right. Okay. Okay. So I think it's clear that the majority wants to focus on increasing the number of customers, sales or products or the market expansions, things like that, right? Good. Okay, okay, let's come back to, you can still vote, right? At the end, I'll get a better picture. So you can continue, voting. So you understand the, sorry, you understand the concept. So if you want to start with big data and data science initiative, don't start with technology. Don't start with, some fancy technological definitions and concepts, right? This I have seen at in many places. This has happened to me as well. When I started with data science and big data, those concepts sound so fancy. And those technology, these advanced technologies, algorithms, machine learning, AI, everything sounds so fancy. You actually want to start with that. You want to somehow implement machine learning algorithm in your organization, right? So that you are starting with that, right? So don't do that. Trust me, don't do that. It ends, very badly, right? And you won't realize the actual value coming from big data and data science if it is technology driven, right? Instead, it has to be business driven, right? So you have to first start the business initiative, right? Now, I'm sure everybody who voted here, probably your current business strategy at your organization, your short-term plan, let's say your annual budget preparation or the annual planning sessions, probably more focused towards increasing sales, right? So you have that in mind. You know that is your business goal, right? Your organization's goal. Your organization's strategy is to increase sales or expand your market or introduce new products into the market. So that is the business strategy. So any big data or data science initiative that you want to start has to align with those strategies. That is the most important thing in starting data science or big data project. Okay, it has to align with this business strategy. So I'm talking about money here because I assume that most of you are business professionals working in profit-oriented organizations, right? But if it is different, if you have like NGOs and government sector, but still they have their strategy, right? They plan their project strategy or the organization strategy first. So whatever the business or whatever the data science or big data initiative has to start from there. And as finance professionals, you have the best view of the numbers, so you can easily start it with your financial statements. right? Okay, I hope I'm clear with that. Okay, so we know where to start now. Now, when you started it, there are do's and don'ts of big data and data science. Okay. Now, these are actually why I want to highlight this very, at the beginning of my session, is these are actually the myths of big data and data science, right? People actually think certain things. For an example, the very first thing I highlighted, data science and big data has to be technology driven, which is wrong. Okay, so it has to be business driven, right? So these do's and don'ts are important to keep in mind. You know where to start, but when you think of starting your big data initiative, you have to keep these things in your mind, right? Okay, just to take you through the correct path, just to direct you, okay? Right, the first thing, this is actually, as I explained, don't think about big data technology, right? Think about business transformation, okay? Now, if it is not a business first approach, okay, which align with your current business strategy, it has to align with your current business strategy, right? Otherwise, say your company strategy is right now to reduce inventory by 10% within this year. And if your big data initiative is planning to increase your product or the SKU portfolio by 20%, that means you will end up with more inventory. So it doesn't get aligned, right? So it has to align with your business. Otherwise, you can't realize the value. Okay. If you start with a technology first approach, as I told you, it becomes what we call IT science experiment, right? We don't want that. Trust me, most of the data science initiatives I have seen have become IT science experiments, right? So as soon as you think, okay, we can apply a machine learning algorithm to increase my sales, and that's all the thinking, and you suddenly call your IT team and ask them to, okay, I need a machine learning algorithm to increase my sales. That's completely wrong approach. Okay. So you have to think other way around. I want to increase sales by 10%. In order to do that, I capture this much of data, which I don't utilize right now. So in order to utilize those data and get more insights, generate more insights, what sort of technology I should use? That comes at the end. Okay. Right. So it has to be business transformation. So this hierarchy is introduced by McKinsey. You can see the technology and infrastructure are the bottom. Those are like tools to deliver value through data science and big data. But the true business value comes at the top. Those are what we call the actionable insights. Data outputs, data analytical outputs, which get converted into insights. Those insights are actionable. You can actually implement it. Those are recommendations, right? That is where the true value is. That's the first thing you need to keep in your mind. The second thing, another common thing, I don't think this is only limited to data science and big data, but in general, have you heard about this term hippo? Do you know who's the hippo in the room? Not the elephant in the room, the hippo in the room. So hippo is the highest paid person's opinion, right? Okay. So this happens quite often. This is very difficult to overcome sometimes. Okay. Now, most of the big data and data science initiatives, those are not collaborative projects. Those are just implementing highest paid person's opinion. So they come up with an idea, they come up with a score or an analytical model that they think which fits, and then they just want to implement it somehow. Again, wrong approach, right? Data science and big data, there are a lot of differences compared to reporting, the traditional reporting that you're familiar with, especially as accountants and finance managers. You all are familiar with this scheduled reports, right? I'll come to that. I'll come to the core concepts of those, right? Which we consider as BI, business intelligence. So BI came before data science, right? BI is well structured. There's a reporting hierarchy. You know what are the KPIs, KPIs defined by the top management, and then you're basically generating predefined set of reports to monitor these KPIs. Data science is not that. Data science is more flexible and collaborative approach, right? It has to be cross-functional, right? It has to be cross-functional. Your IT department cannot deliver a data science project alone, a successful data science, right? If it is related to finance, people from finance team has to be there in that particular team, right? Providing the experts or the experience, the domain knowledge for that data science project. You need IT people to implement the technologies. You need data scientists to create statistical or advanced machine learning models. You need data engineers to come up with the best suitable data engineering technology to implement, right? You need your business analyst to communicate between your finance team, which are the users, and between the data science team, right? So it's a very collaborative approach. It's not that your top management decide a particular scope and then you implement and prepare predefined set of scheduled reports to support that. There's a big difference. So it has to be collaborative. Keep that in mind, okay? The next thing, now I'm coming to the actual technologies. BI versus data science, right? This is one area you need to clear out, properly, right? Because I'm sure as finance professionals and accountants, you are pretty much, following this BI concept, right? So BI or business intelligence, actually, like if you look at the history, how these concepts came, now BI came before data science, right? So before big data, so big data whole concept started in like early 2000s and especially after 2010, right? The second decade in this century, right? But you are pretty much familiar with information system like even 3-4 decades ago, right? That is ERP systems, your accounting systems, your procurement management system, your POS system, point of sale systems, right? So that era, actually, we call that information era, right? They created summarized reports for you to follow through, right? They have monthly reports, daily reports, or maybe even like real-time reports even, right? So that part, these summarized reports, predefined set of reports and KPIs, that information era was driven by a transactional system, what we call operation system or the information systems, and with the support of BI technologies, right? So when you say BI, don't get confused with data science, right? Okay. I'm not saying BI is bad. Huh? Don't get me wrong. You have to have completed your BI cycle by now. I'm sure you or most of you have done it, because if you take most of the organizations now runs on information systems, right? Those data get collected. And you often, even the system reports, supports a lot of predefined set of standard reports. But anything else, you can download the report and use some BI tool like Power BI or Tableau or even Excel, Microsoft Excel, and prepare set of reports. And through your reporting hierarchy, you can communicate it with the stakeholders. Data science is different, right? So if you want to harness the true potential of data science, you have to separate your BI reporting channel from your newly or the planned data science initiatives, right? Okay, I'll tell you why. I'll explain it one by one. Now, business intelligence, if we take this traditional BI concept versus data science, there are some common grounds, right? There are some common grounds. That is, if you look at data visualization and data management, that part is common for both these methods, data science and business intelligence. Both uses data visualization techniques, right? It could be a BI platform or a visualization platform, or else some other system generated graphs. There are separate, several methods of visualizing data. And then the data management, how you connect to different data sources, right? So those parts are something in common, right? But the differences are more, okay? So business intelligence, as I was saying, are descriptive in nature, right? You ask the question, what happened, right? That's the key difference between data science and business intelligence. So BI asks, so BI questions and the reports and the outputs are descriptive in nature, right? And they always use structured data. That is your operational systems, transactional systems. Those are structured data. Why we call structured data? Those are run by using a database, right? Probably you have heard about this database management system like MySQL or MS SQL or PostgreSQL, right? All these SQL, standard query language type of table structures. We call them structured data. And your organization runs on those information systems, right? And I'm sure most of the organizations right now are matured in this cycle. They have gone through sometime second, third cycles of implementation or updating the ERP systems, right? So they have set of structured data sets. And then always you generate reports and views. So those are predefined structure. Okay. And it's a sequential process, right? It's a straight line. The process is sequential. You have first step, second step, third step, right? It's sequential. And the most advanced, you can't say most advanced, but nowadays the most matured level you can reach with your BI function by utilizing a data warehouse, right? So data warehouse is something you use as a central repository to connect to all your operational systems, your transactional systems, right? And generate reports and views through a sequential and predefined hierarchy. Very structured. And I'm sure most of you are pretty much familiar with that process, the BI process, right? But data science, there are differences. Now, instead of asking what happened, data science asks the question, what will happen? And what to do about it, right? We call them predictive and prescriptive analytics, right? So predictive asks the question, what will happen? Okay. Prescriptive asks the question, what can I do for that, right? Or what to do about it. Okay. Predictive actually generates an insight. Prescriptive convert that into a recommendation or an action, right? That is why we call that generating actionable insights, right? And when it comes to data, now BI completely runs on your transactional system generated data. All are structured table format data, right? Actually, these SQL databases are the most structured data organizing method that you can think of, right? Very structured. But when it comes to data science, the true potential of data science comes when you incorporate big data. So when I say big data, that is not your transactional, traditional table, tabular structure views. I'm talking about unstructured data. That is 80% of big data. Not even big data. If we consider all the data we consume and we use right now, we are using more than 80% of unstructured data, right? I'll give you an example. Right now, without knowing, we are using a lot of unstructured data, right? We are using a lot of unstructured data. Just one example, your mobile phone. You're sharing probably your location right now. You are getting updates through your Facebook, Twitter, and Instagram, or any other social media account. You are getting updates from your news subscriptions, right? You are receiving your emails, okay? So without knowing, you are using unstructured data, right? There was an estimation sometime back by, this was sometime back somewhere in 2017 or 18, if I remember right. There was an estimation by 2020, every person in planet, that is 8 billion people, will generate 1.7 megabytes of data for every second, right? For every second, every man and woman on this planet, right? 8 billion population will be using 1.7 megabytes of data. Okay, that's the amount, that's the volume of unstructured data that we are using right now. So true potential, that's how this data science knowledge area was built to handle big data and to generate insights, generate actionable insights by harnessing these unstructured data, right? So even within your organization, you are using more unstructured data than structured data, right? You will feel like, because you have that thinking, you have that feeling when you actually download a report and, you know, open an Excel sheet and then, you know, entering some data, you feel like this is data. But think of your emails, think of all the product catalogs sent by your suppliers through PDF, through email, or through any other e-publications, right? Think of all the other announcements that you, right? Chat apps that you use within your organization, right? Those are all unstructured, right? Those are text, images, videos, right? It could be some other things, sounds, right? So that is where what we call the unstructured data. So 80% of the data ecosystem right now are unstructured data. Okay. So data science, the true potential of data science is when you incorporate these unstructured data into your analysis. Because in BI cycle, most of the companies, they have, as I told you, they have matured to the best, or the top, they are using their best quality data warehouses. Their reporting is real time. Okay. Monitoring process is real time. Okay, all the KPIs are monitored correctly. So the governance process, data security policies, everything is done. But there is a completely untapped area with unstructured, or what we call sometimes semi-structured data, where you can generate more insights, right? So that is where the true potential, right? And then now this BI process is very structured. As I told you, it's a sequential process. But data science is an iterative process, right? If you're familiar with these agile concepts, right? Or if you are related to IT or software companies, probably you have heard about these Scrum practices, right? So that is what we call an iterative process. So it goes cycles and cycles. So you can't put, sequential deadlines to a data science project. It has to, once it goes through a cycle, probably it collects more data, more insights. And with that experience in hand, you have to run it in another cycle. Then your models will improve their accuracies, and the insights, the quality of the insights will be more, right? So it's an iterative process, right? Okay. And in terms of technology, now we know data warehouse is used with BI platforms. In data science, we use, because now a data warehouse supports transactional data, right? Supports transactional data. Now, when we have a lot of unstructured data, you can't use this structured method of data warehouses and SQL database. Instead, we are using something called data lake. Data lake is something you can dump anything, whether it's unstructured, whether it's text, whether it's images, or social media post, any API data, mobile data, geospatial data, right? That is location related data. Anything you can just dump into a data lake, and through a tool set, what we call the data scientist tool set, we can see where we can get data and process it and generate insight, right? So this you need to identify clearly, right? Because this actually connected to another thing that I discussed, that is calling your IT team at first, right? IT team probably is your BI team, and most of the time organizations using a separate BI team, or you call them MIS team sometimes, right? So those people are experts in creating reports, okay? If you ask to generate a customized report, they will do it in a second, right? They're experts in SQL databases, working with data warehouses, generating reports, right? They are experts. But when it comes to data science, the core of data science is not in that. It's in creating an iterative model which automatically improves its ability to generate insights, actionable insights, and you have to monitor the accuracy. That's why you need data scientists, data engineers, business analysts, and domain experts, right? Okay, so understand this. If you want to do big data with data science, you can't go through the traditional BI thinking. Clear? Right? Okay, right. Now, I told you this difference. This is again BI versus data science, but since I'm sure, that's part of the evolution process, right? when the information systems came, the transactional systems came, you saw the opportunity to real-time monitoring your current situation or just monitoring what happened, right? So then BI knowledge area got created and it evolved into a very matured and advanced level right now. Okay, you can monitor your business organization real time, right? But it doesn't generate actionable insights real time. That is the difference. Okay, right. So now, when you have achieved your BI competency, BI maturity, then you can start thinking of predictive and prescriptive questions that you need to ask. Okay, now how you can do that? Now, for an example, let's take sales, because most of you said that you are focusing on sales, right? Say an example, the descriptive part, right? So keep in mind these three concepts: descriptive, predictive, and prescriptive, right? So descriptive is more BI. Predictive and prescriptive are more data science, right? Okay. So now probably you are monitoring or probably generating reports like last month's sales volume for item A, right? Could be sales value or sales volume. So you are generating a report at the end of the month or probably the first week of the next month. How much items, product A items I have sold during last month, right? That is the descriptive question that you ask. What has happened, right? Okay. Now the predictive question that you should be asking, if you are, coming towards the data science, what will be your next month's sales for item A, right? So you're asking the question, what will happen, right? What will happen? Prescriptive ways, you know what will happen, right? In order to facilitate it, what you should be doing, right? For an example, the prescriptive part would be, in order to achieve the next month's forecast, you need 20,000 units of item A by end of this month, right? So that is what we call prescriptive. That is a recommendation, right? So how that happens, there's a process. Okay, so last month's sales is your actual data. You have the actuals with you. You have last month's data. So you just generate the report, just running a query. That's it. Okay. Now, when that became predictive, you need a forecasting model, right? That's where the data science modeling comes in. So you need a predictive model. So using that predictive model, you forecast that next month's sales volume for item A be this much, right? You convert that into a prescriptive model by connecting that into inventory and procurement, basically reorder levels and reorder quantities. So you know the forecast, you know the current inventory level, stock in hand, right? So in order to match that inventory level, you calculate the number of items to be replenished, right? That is another model, another automated model, right? It's more like optimization on simulation model, you can say. When it comes to inventory, we'll discuss more about this with our case study next week. Then the combination of predictive and prescriptive will tell you, finally, recommend you to order 20,000 units of item A by end of this month, right? By end of this month, right? Okay, I hope you understand the cycle, right? Okay, let's take another example. If we take customer turnover, right? Customer churn, let's say it's a big problem, especially with e-commerce and, mobile app-based businesses, and for everyone in general, maybe service industry, right? So let's take customer turnover, right? So you calculate the descriptive part is what was your customer turnover last year, right? And the predictive part will be expected customer turnover by end of this year. So you have to predict, you have to forecast, right? So you achieve that number, right? Okay, what would be the prescriptive question, or what kind of a prescriptive model or output you can get if you continue this with the customer turnover? So I have created another poll because I was, explaining so much, right? Just to get pure interaction into this, I have created another poll. I have given 3 options actually for you to select. Let's wait till it loads. Right. Okay, we already have an answer. This has a right answer, okay? So just be careful when you answer. So let me just paste it in my chat. Oops, what? Also, you can scan the QR code. So I have given 3 options, right? Now, if we continue with the same thinking about customer turnover, so descriptive is we know that you want to know the customer turnover in last year, right? You captured that. Predictive will be expected customer turnover by end of this year. Out of these 3 options, what would be the sorry. Oops, something happened. Let me open it again. Yeah. So out of these 3 options, what would be the correct prescriptive model or a prescriptive output, right? So the first one is there is a 5% increase in new customers last year after providing 5% discount. Okay. Read that carefully. Second one, offer 15% discount to the loyal customers, which will reduce the customer churn by 25%. Right? If we offer 15% discount to our loyal customers, the customer churn or the customer turnover will reduce by 25%. Right? Third option, the correlation between the discount and the discount given and the customer turnover is minus 0.25. Right? So that is like every discount given, there will be 0.25 times reduction of the turnover, right? Okay. Go read through this carefully and think what would be the best prescriptive model to match the customer turnover. So I'll give you like a couple of minutes for you to think. I just want you to understand this, the thought process, which is important. You have to ask the right question always. In data science, it's very important. Okay, I'm getting some answers. Okay, maybe another 30 seconds. Okay, I think we have actually right answers. The second option, right? Because the first option, it's still descriptive in nature. If you just read it carefully, you will realize what it says is there is a 5% increase in new customers, something completely unrelated actually, because we are looking at our existing customers and their turnover. So this tells you something different, but it's descriptive in nature, right? It says 5% increase in new customers last year after providing 5% discount. So last year, to acquire new customers, they have given a 5% discount, right? I have just briefly summarized it, okay? But I hope you understand the gist. So 5% discount, they acquire 5% more new customers last year, right? It's descriptive in nature, right? Something that already happened, but you have generated a report out of it. And this one actually between descriptive or inside descriptive, there's a branch called diagnostic analysis, right? Or we can call it exploratory analysis, right? That is finding the root cause, diagnosing the root cause for what happened. Nature. It's not predictive definitely, right? It has already happened. So you are looking at why it happened. So you are trying to understand the root cause. So the first option and the third option are both diagnostic or exploratory in nature, right? Something has happened. Based on what happened, you need to understand why it happened. Right? But it doesn't ask the question, what will happen, right? Okay, it sounds so philosophical, but this is how you are, try to build the right question in data science, right? If you have the right, if you are asking the right question, trust me, I mean, whether you are a data scientist or not, you are on the correct path. Okay, problem with a lot of data scientists is actually they don't ask the right question. Okay, sadly, that's the truth. So because they don't get familiar with the problem domain first. They are so, this applies to me as well, but they're so fascinated with the data set. If it is a large, fancy, unstructured data set, we are so overwhelmed by that size of the data set and the advanced, details or the data points available in that data set. And we are so excited about, the ability to, use an advanced technology to process this data set. So we get overwhelmed sometimes, right, with those, right? But actually, we need to spend more time on understanding the problem domain, right? So that is where you come. That is your expertise. If you are working in finance, if you are trying to implement something, you know by experience what are the problem comes in this domain. What are the problems that you need to solve, right? That's a very good start. So that's why I always believe like the great data scientists are coming from non-IT, non-computer science background. Trust me, right? That's the truth, right? Luckily, I don't think we have many computer scientists here, right? But that's the truth, right? You have to always ask the right question. Right. Okay. I hope you understand the thought process, right? So the prescriptive model would be offer 15% discount to the loyal customers. That means it's a recommendation. It says to offer 15% discount, and that will result a 20%, 25% reduction in our customer turnover. Okay. So I have another example. Let's talk about profit. Say company's profit last quarter. Descriptive in nature, right? What happened? What was our profit last quarter? Projected profit for the next quarter. That is predictive. So you need models to accurately predict the profit next quarter, right? The prescriptive part would be, in order to achieve the profit goals for the next quarter, you need to optimize your product mix, right? And XYZ is the right product mix to achieve that profit or the margin goal next quarter, right? So it's an optimization, it's simulation. So prescriptive are more into optimization modeling and simulation model. Predictive are more into forecasting basically, right? Predictive in nature. Okay. So I hope you understand the process, right? Okay. So that is about main concepts, do's and don'ts of big data and data, right? Okay. I'm just building your, the way you need to think. That's it. I'm just directing you to think properly in data science and big data, right? Okay. So now you know where to start, right? Now you know why you need to start, right? And you know when you start, what are the things you need to do and what are things you don't want to do, right? In order to make more money through data science and big data, right? Now this part, again, this will be kind of I prefer this to be more interactive one. So I expect everybody to do this with me. If you have small, I don't know, maybe a pen and pencil would be enough, or if I think you got your presentation deck, so you can follow it there. But when I'm doing this, I want you to think through, or rather try to apply it to your context, right? Basically to your organization, what you are doing right now. Okay. This part is called Big Data Business Model Maturity Index, right? If you have heard about maturity indexes, this will tell you that, this data science or big data or any process, any, change that you bring into a business organization, you can't just dump it, right? It's more of a journey, right? So you have to follow through a cycle of maturity in order to achieve your final level, right? Data science and big data are no different. It's not something fancy, or it's not magic, right? It doesn't give you a magical solution for every problem you have within your organization. You can't just dump in big data or data science technology. You can't just recruit one data scientist and expect him to deliver magic at the end. It's a journey, right? Okay. So in that journey, you can't, as soon as you started the journey, you can't achieve the destination. You have to follow through the correct milestones in order to get to the end, right? Achieve the destination, right? So maturity index is that. It's actually a very good tool set, right? I'm sure some of you have heard about these maturity models, which actually why you need this is to evaluate your current position in this journey, right? You need to evaluate your current position, where you are right now, right? So we answer the question why and how, right? But now you know what to do, but you need to first check where you are right now. Okay. Okay. So this has 3 layers in the maturity index, in the maturity model. First, we'll discuss about these 3 layers, right? These are internal to the organization. Okay. These are within your control, these 3 maturity layers, maturity levels, right? These are within your control. Actually, if you put the effort and if you follow through the correct path, you can achieve this maturity level and come to the top level, which we identify as business optimization, right? That is the internally within your control, the highest you can achieve in this maturity model, right? This is using big data or utilizing big data and data science. Each level of maturity you have to pass, okay? Of course, everybody loves to jump right into the business optimization, right? Without doing anything else, right? That would be ideal, but you can't, right? There is a learning process, there is a change management process, there is a process of getting top management buy-in, which is very important, right? There is a cycle time to learn things and internally build this knowledge area. So that's why we have introduced this maturity index or maturity model, right? So it first starts with what we call the business monitoring stage. Business monitoring is exactly what we discuss as descriptive or as business intelligence, or in terms of technology, we discuss with data warehouse. That is all comes under business monitoring, right? Business monitoring is you have the ability to report and monitor your current business performances, right? This is what all of you are good at, right? I'm sure, right? As finance managers, as accountants, as top managers, right? As executives, this is what you do. Generating reports, maintaining KPIs, creating real-time dashboards, everything comes under business monitoring stage. Okay. So that's the first layer. So once you have achieved this business monitoring phase, you know what has happened, or you have complete view of your internal data sources. You know everything about your information systems, the data you captured in those, the reports you generate, the KPI scores that you have created, real-time dashboards or BI platforms that you are using, right? So you are all capable with that. Then you can go into the next level, which is predictive level, or what we call the business insights, right? That is the predictive modeling part, right? Answering the question, what will happen, and generating insights, right? Generating insights about customers, generating insights about products, about markets, about your operation, about your cash flow, right? Generating insights. And finally, after you matured in generating insights, you can convert those insights into recommendations or actions. That is where the business optimization phase comes, right? If you are in the business optimization stage, that means using data science and big data models, you're creating recommendations and executing those recommendations, right? So that is the business optimization phase. So we have a small toolkit. So it's actually this is actually kind of a consulting exercise, or rather, that is how I got involved with this. This is actually a very lengthy exercise. Sometimes you have to, check a lot of boxes, right? But I have summarized everything into a very small scale maturity assessment, right? Under each section, right? So what we'll do is, it's better if you have at least a pen and a pencil, sorry, a pen and a paper, or a pencil and a paper. So while I'm explaining, I want all of you to think your initial project that I asked you to select, okay? And most of you, I think, most of you selected something related to sales, right? About increasing customers, products or markets, sorry, right? But I'm sure you have something specific in your mind, okay? It could be like increasing your personal care items if you're in FMCG, just an example, right? Or increasing your customer footfall if you are in retail business, right? Increasing online customers, something like that, right? I'm sure you had something in your mind, okay? So I want you to think of that initiative, right? And answer these questions, or just check, or rather tick these boxes, okay, under each criteria. So what I have done is, this is not the way we do it usually within an organization, but this will give you an idea on how to plan it out, right? But I expect you to, implement this in your organization, and when you do that, put more effort and time to actually think of this, right? Right. Because this will give you the clear visibility at the end where you are right now, whether you are capable of implementing the AI technology that you want in your business, or rather you have to first generate a simple forecast by averaging last 3 months sales, something like that. Okay, right. So this is how it goes. Right. So I have taken all 3 steps: business monitoring, business insights, and business optimization, 3 layers. And I have these 5 boxes, right? 1 to 5. 1 is the lowest maturity. That means you haven't achieved it yet, right? Yet to achieve. Okay. 5 is you have already implemented it and successfully using it, right? You have done it. You have achieved the highest level of maturity in that criteria, in that area, right? Okay, understood? Right. So I'll explain the criteria one by one, right? When I do that, think of your business initiative and think of your organization and try to find your scope. Just put a tick there, okay? Based on the level of maturity. 1 is you haven't implemented it. It's not a current practice in your organization. 5 mean that is successfully implemented. 3 is somewhere like you have taken initiatives, but it's not, the success is yet to be measured, something like that. Okay. But 5 is you have done it. You have achieved and mastered that criteria. Okay. Right. So the first criteria, now, if you are in business monitoring, right? Trust me, at each phase, I have indicated this, that is getting your top management's buy-in, right? You need your senior management's backup. I'm sure that is true for any change management or any implementation that you do, right? I'm sure you have a lot of experience in that, right? But trust me, that's so important. That's why I have mentioned it. That is at the strategic level, okay? Right. So in business monitoring, first thing you need to understand, first thing you need to check is whether your KPIs, your reports, monthly, weekly, daily, or maybe even hourly reports, probably real-time reporting, and your KPIs, performance matrices, are defined, measured, and those are aligned with your current business strategy, right? Okay. Say, for an example, many of you selected sales as your business initiative. That means probably your current business strategy, current organization's goal is to increase sales, right? Just think in your mind, all the sales related, revenue related matrices, KPIs, and reporting structures are defined and measured as at now in your organization, right? If it is measured in real time, you have a nice looking dashboard, just log into the dashboard and you can monitor any sales related KPI. What is my current footfall? How many number of customers, new customers registered today for my e-commerce website? Or how many new loan applications you issued right now? How many got approved? All these KPIs, right? You are the business expert, so you know more than me what are the related KPIs for your organization. Just think whether everything is defined and measured and you can access any time and monitor your business performance, right? If it is true, maybe it's 4 or 5, just you can be subjective in the scale, right? If it is not, 1 or 2. Okay, right? Got it? Right. So if you have achieved very high level of maturity in business monitoring, that means you know about the scores, you know what are the main performance matrices to run your organization, to monitor your business performance, right? That is very important because you can use that for business insights and optimization. I'll come to that, right? But first thing, you need to have your set of KPIs, performance metrics, right? And the data which measure those KPIs has to be perfect, has to be accurate, has to be at least near real time, right? So first important thing is that, right? And then look at the organization. Think from the people and the organizational hierarchy point of view, whether you have a dedicated BI team or a MIS team. You call it MIS team, BI team. I don't know what are the other names you explain, because I have seen, I'm not sure about other countries, but here I have seen a lot of MIS teams are under finance, right? I've seen that. But sometimes it's under a separate team or under a separate head. Sometimes it's under IT, right? But it's separate. You have dedicated BI team or a MIS team. Then you have that knowledge, right? Trust me, when you have the MIS team, dedicated MIS team, since you request hundreds of different customized reports from them, right? Most of the MIS people, or rather the experienced MIS executives in that team, are so familiar with your internal data sources. They can even, by heart, they know the table names of in the SQL database, in the backend, right? So if you have people like that, it's so easy for you to get your internal data done, right? So easy, right? That's a very good advantage. Otherwise, if you don't have dedicated people and the person who created that database has left, right? Or died sometimes, right? In certain legacy systems, then you don't know what's in your database, right? You don't know where this data value is generated, right? Okay. So if it is one or two, it's not that good, right? You have to work on business monitoring before you move into other phases, right? Okay. Then whether you have very structured way of defining your BI models, whether you update those models frequently, and whether you check the accuracy of those data. Again, it's very easy if you have a dedicated MIS team or BI team, right? Then when it comes to the technology or the infrastructure side, you have to think all your transactional data, that is your internal ERP systems, accounting systems, procurement systems, POS systems, e-commerce websites, everything, whether those are integrated into a data warehouse. I'm talking in BI sense. We haven't come to the data science part yet. But achieving maturity in BI will give you an edge, will make your life easy when you are, converting that skill set. You can't do with BI thinking, right? That we established, but you can convert those skills nicely, convert those learnings into your data science phases, right? That's why this is important, right? Achieving maturity in your business monitoring phase. Okay. So if you have nice looking data warehouse integrated with all your transactional data, right? All your structured data, internal data sources, that's nice, right? And whether you have BI or a visualization platform, say Tableau, Power BI, Click, or any other sort of, there are a number of BI platforms and visualization platforms right now. Okay. So whether you are using that, so is it just you have to download as a report every time through the system, or you have a BI platform, you can just log in and look at all your sales related KPIs right now. Okay. Right. That's the difference you need to understand. Then infrastructure side, I don't expect you to be experts in that, but just ask your IT team whether you are running all your infrastructure in-house or is it cloud-based. If it is cloud-based, you have an advantage. I'm not planning to discuss the pros and cons of going into cloud. That's a separate discussion. But if it is cloud, we have an edge towards our data science phases, because cloud platforms are easily scalable and flexible. You can use those resources, right? That is the advantage, right? If you are running everything in-house, if you have big server room, then everything depends on your IT team when it comes to infrastructure, right? Okay. So answer these questions or rate these criteria 1 to 5. Think of your strategy or the business initiative you thought at the beginning of my call, right? And try to apply this. Okay. And finally, you can get the average of this score, right? So if this one, it's something 25, so we have 6, right? Yeah, so roughly this comes to around 4, right? The total average score. This is not what we usually do it. It's a very lengthy exercise. And you can assign certain weightages for different criteria. But say simply you can get an overall understanding about your current, data science and BI maturity of your company, right? Okay. So if it is 3 or less than 3, before moving to data science, you have to work on your internal business monitoring phases your KPIs, performance monitoring, your internal data sources, integrating those internal data sources, identifying those internal data sources, and your current technology and the people involved in that, right? Before you move into data science. If your business monitoring phase is not matured, don't expect you to, having magical solutions through data science, right? That's number one. That means if you are not mature in this phase, that means even you don't have any idea about your internal data sources, right? Okay, let's forget about the unstructured data and secondary data in coming in the data science phase. You don't know your data, right? So you have to build that awareness. You have to work on these criteria. Okay, understood, right? But if you are in 4 or 5 in business monitoring, I'm sure and I expect a lot of people to be in that level, because I know organizations are spending so much on BI platforms, visualization, data warehousing, right? They are doing a lot of investment. So I would love to see more organizations have achieved this level of maturity, right? At least like 4 or 5. Okay, right. Now, if you are in 4 or 5, then come to this level. Now, if you are in 4 or 5 in business monitoring, you know about in and out of your internal data and the KPIs and things that you need to monitor. Correct? Right? So then it's easy for you to move into business insights. Now, when we are generating insights, the approach changes. We discuss about it. How you are thinking about why, what will happen and what to do about it. You are talking about data lakes, not data warehouses. You are talking about data science, not business intelligence at this phase, right? Now, how the things will change. Now, in first monitoring phase, you have identified KPIs and everything, scores and everything, right? Most important thing now, it should come from your leadership, which should come from your top management, is to incorporate big data and data science as part of your business strategy, not as a siloed, separated experimental project. Right? You have to get management's buy-in to execute a data science project successfully. See, based on my experience, all the things we start as experiments, those eventually fails, because it's so difficult when you start it as an experiment. It's so difficult to realize the financial benefits of it. It's very difficult to convert it into cost saving or profit increase if you don't implement it. If you don't implement the actions generated through your data science models, it's very difficult. So after the experiment, it's very difficult to convince the management. You have to get the buy-in from the beginning, right? I know it's very difficult, right? But that is something we need to do. It has to come from the top layer, right? Number one, just think whether you're, see, like the business leaders, they like to talk about this concept, but when it comes to the implementation, sometimes it becomes difficult, right? But you have to actually back in these initiatives, rather making it a science experiment in a controlled room. Okay, you can't do data science like that, because the realized actual benefits comes if you implement the recommendations given by the model, right? That is number one. Then, not your BI team, not your MIS team, you have to create a cross-functional data science team. This doesn't mean hiring 1 or 2 data scientists who has done a PhD or a master's in statistics or data science, and then you ask them to deliver, right? It's not. You need to assign people from, say, if you are making a sales related initiative, the sales people, marketing people, brand managers, finance people, supply chain personnel should be in that team, because it affects everyone, right? You have to get insights from everyone, right? If you implement a forecasting predictive model and only you are allowing salespeople to override the forecasting value manually, and then the model runs at the sales end, but you never incorporate the procurement people's supply chain and especially inventory managers, warehouse managers insights into your model, then it doesn't matter how well you forecast, you can't deliver because you don't have enough stocks, right? Your supply chain is not planned to match that demand, right? So it has to be cross-functional. It's not, doesn't matter whether you recruited the most, most intelligent data scientist into your company, if you can't create a very cross-functional initiative around it. They will deliver what they are good at, but they need to understand the problem domain, your practical situations. That has to be modeled, otherwise it won't work, right? So it has to be cross-functional. This is not like a dedicated BIMIS team. This is a cross-functional team. Keep that in mind, right? And then most importantly, and this is what most of the data scientists are struggling, and now we are actually trying to work on it, finding new concepts. We call it trusted analytics, or rather we can call it trust in analytics, right? This is one area we can say failed to convince other people. Because the problem is, unless BI, the models are so visible, right? It's in your Excel cell formula, right? You have calculated your inventory days or inventory turnover. It's a simple formula. But the thing is, in data science, most models, if you take machine learning algorithms or deep learning algorithms, all those are black boxes, right? If you want to know what's happening inside the model, you have to start learning mathematics and statistics, right? Okay, so it's a black box. Say you are using a machine learning algorithm to predict your customer risk, to label your customer. Say for an example, in a bank, you want to know whether this customer will pay or whether he'll default, right? So you label them and run a classification algorithm. Let's call it anything. Let's call it random forest, right? So you get the output and it says 85% of accuracy. 85% of the time you can accurately identify a new customer, whether they will pay or they will default, right? But when you take this to the management, right? If the management asks how you arrive at this number, right? You can prove that, like if you are good in math and if you understand the math, the calculation of it, you can explain it. But unless your top management, mathematicians or statisticians, I don't think they will understand, right? Okay, so when it comes to this, it's very difficult. So you need to identify different, data scientists will always produce you with statistical scores. We always come up with statistical accuracy, right? Forecasting errors, everything is statistically measured, right? But you have to implement it in the real world scenario and test it out. So you need business validation. So this is an area we need to work on. And in terms of the quality, effectiveness, integrity, and resilience of your models. Resilience is also important. We had first-hand experience with this with all COVID and the current economic situation. With COVID, if we take Amazon, their all replenishment cycle runs with prescriptive models. So their replenishment is automated. So when the COVID came, all their buying patterns changed, right? So the forecasting accuracy reduced, that means forecasting error increased, which affected their replenishment model, right? So the prescriptive part. Okay, so they reordered based on the previous or the old forecasting model. They didn't have enough data to come up with a new forecast based on the changed customer pattern, customer behavior, right? So they ended up with a lot of inventory at the end. Okay, because buying pattern changed, right? So we have so many things there. That is something I think as data scientists, we need to focus on. So that's why this concept came with what we call the trusted analytics. So that is some area that we need to work on, but still we need to establish that. The best thing to do is validate it with business points, right? Then again, we are coming into BI versus data science. We are working with unstructured data, right? Unstructured data. And we need to have a separate data science platform. This is what we call a sandbox. Not your BI structured tool sets, a sandbox, which they can run their iterations. There are a lot of tools and technologies available. I'm not going to discuss about those, right? But you need that. And you need a lot of flexibility in terms of your infrastructure. That's why I told you, if you are in cloud, if you have learned the maturity of cloud platforms and using cloud platforms, that becomes an advantage when it comes to data science, right? So think in terms of business insights, where you are right now, right? I don't expect you to, achieve 4 or 5 in this, because I know this is where a lot of companies need to start thinking and initiate data science activities, right? Okay. Then finally, you achieve the ultimate level, which is called business optimization, right? At this point, you are working as more like a data-driven organization, right? Most of your recommendations, most of your business actions that you take are derived from data-driven models. Your replenishment, your customer acquisition, your customer risk analysis, right? Your cash flow forecast, your debt collection process, SKU rationalization, inventory optimization, driven by data-driven models. It recommends and the recommendation get implemented, right? Now this, we are creating a loop back to BI, not actually BI, actually for the operational systems. Because when we created an optimization model and when we get the output, that output get implemented when we feed that recommendation back into our operational or the transactional system, right? Let's take forecast. We run the forecast, and if we want to see our procurement or the replenishment plan, you need to write it back to your ERP system, right? Okay. This is actually very interesting phase, but these are the like to do's in data science. But in order to cover these like to do's, you have to do must do's first, right? Must do's are, somewhat hectic and boring. Nobody likes it. But in order to come to this level, and this is the phase where you can actually realize the value of big data and data science. You can measure the value generated from data science and big data. You can convert into rupees and cents. Okay. You can measure the cost saving. You can measure the working capital improvement. You can measure the sales increment, right? This is the phase where you get all of this. And in order to do that, your scores, your KPIs and everything in this phase, what happens is it get converted into what we call objective functions. Objective functions, it's a technical term that is the input for optimization and simulation models, right? Your KPIs, your performance matrices get converted into objective functions. For an example, profit maximization, cost minimization, risk minimization, right? Number of SKU minimization, number of dealer points minimization. That is what we call an objective function, right? In order to run this, you need a separate data organization within your business, right? Usually now this term is, I know there are a lot of chief officers now, but the CDO is, this CDO is not CIO. There's a big difference. So CIO or CTO, those are the people who are managing your technology part, your infrastructure. CDO, Chief Data Officer, is the one who can generate value through your internal and external data sources, right? So they have created a separate organizational hierarchy to support business optimization phase, right? And you can quantify the value generated from these analytical models, right? Okay. And from the infrastructure side, you can automate a lot of these things. So automate, I'm sure you are these days, you're hearing this robotic process automation, and rather RPA, there's a new term. We love to introduce new fancy terms called intelligent process automation, right? So that is something coupled with data science and automation, right? So automated forecasting models, automated replenishment model, automated customer risk analysis models, right? That is how these things happen at the business optimization phase. So you are running a data-driven recommendations. Your actions are always connected to an objective function, which generates insights through a data science and big data process, right? Again, I don't expect you to be in 4 or 5 in this, right? If you are in 4 or 5 in this level, brilliant, right? You can, transcend from your current position. I'll come to the other part, right? But just use this as a tool, right? Right now, I don't expect you to be in 2 or 3 in business insights and 4 or 5 in business optimization. You can't do that, right? As I told you, it's a journey. Okay. But keep in mind the path, the level you can achieve. So use this as a tool. You can expand this. Actually, if you want more details and how to do this exercise, and if you want to discuss certain areas, I'll be happy to answer, right? But this is a very good exercise just to see where you are in terms of data, in terms of big data, in terms of data science. Whether you are in a position to start data science initiatives at your organization, right? So use this and just get an average score under different layers and see what are the gaps are, right? So this, as I told you, this covers high level criteria, but this gives you an idea, right? Okay. So now, if you achieve business optimization, I told you this is your limitation within your organization, within your control, internal to your organization, right? Beyond this, what will happen? Actually, I don't like to explain this too much because people get so excited with these topics and concepts, including me, okay? Right? But this is where the fun part is, right? So you are not controlling your internal data, but you are more than that. You're monetizing your data. That is a major shift, okay? That is a major shift from business optimization level to data monetization. You have to be at your level best in the business, of not at your level best, has to be like compared to competitors. Even you have to be in a very good position, very good maturity level to start with any data monetization activity. So data monetization, what happens, you create products out of your data. Basically, you sell data, right? You create, there are different ways you can create products, data products. One is you can package data. If you have heard about APIs, this is what data companies do, right? Okay. Say for an example, Facebook package your data and sell it as a product through an API. Twitter does it. All the social media platforms, they do it, right? Or else you can convert it into analytics and sell it. Do a value addition to your data and do it. Say like Google Analytics in your websites. That's what they do, right? They sell analytics for you. That is your data, okay? But they sell it to you, right? And then you can repackage multiple different insights together and create new products. So you can be very innovative in this space. But unless you have achieved your business optimization, the highest maturity of within your internal organization, you can't think of monetizing your data. Data monetization is not just selling reports or selling your customers' addresses and the phone numbers, right? It's more than that, right? So I'm not going to explain further about this. And there's another one. This is not the end, right? You can go further, right? We call this phase data metamorphosis, right? Metamorphosis, you know, the natural metamorphosis process, right? So we apply that to businesses. This is a complete business change, like shifting paradigms, right? Okay. So this is, so far, this is the best they can achieve. Like basically they are selling business as a service. This is what the data companies, some data companies do. Say for an example, if you are an automobile company, now Tesla looks like an automobile company, right? But it's more data company than an automobile company. So instead of selling vehicles, they sell mobility. That's their bigger plan, right? Say if you take Airbus, instead of selling airplanes, they sell air miles, right? So they create a separate platform where other businesses can join, right? Other businesses, say if you are selling air miles, if your business is selling air miles, all the traveling companies, ticketing agents, everything will get connected to that data products, that data business. So you create businesses out of your data, right? Okay, sounds very interesting, right? But I'm not going to talk about more on this. These are, you know, very difficult. And personally, I don't think I'm qualified to explain this because I've never worked in a data monetization project, okay? Nobody has done it. I would love to involved in one, but I haven't so far. But these are more business level decisions than data scientist work, okay? But this is what you should target, okay? This is what you should focus from business monitoring, how you can achieve this business optimization phase, right? Okay, so we have come to the end of our first session, right? So idea here is, I just want you to understand differences and why, how, and where, right? Those are the points I need you to, you know, keep in mind. right? So next week, we'll see how we can apply this into a practical real world experience. All right.
All right. Thanks a lot, Mr. Thisara. It was very informative, very interesting. And I'd like to request you to answer a few questions from our participants, which is in the Q&A box.
Sure.
Do you want me to read for you, please?
Yeah, I think it's better.
All right. The first question, Ruani Rubasinghe, asked by Ruani Rubasinghe. She would like to know the opportunities that are available to earn online through big data analysis. If there's any freelance options or part-time, something like that. So could you please elaborate on that?
Yes, there are opportunities. There are actually now this whole data science area creates number of different job opportunities, right? So if you are coming from a domain knowledge, right? Especially if you look at platforms like TopTel is more like, professional platform where you need to pass some exams and, register. But then if you take Upwork, Fiverr, those platforms actually offer more detail or other like very specific projects in terms of data science. Say if you are not into the technical side, then you are working in between, right? A lot of financial experts, you can play that role, which connects data scientists and the business people or the customer. So you are more like in a business analyst kind of a role, right? Where you can use your traditional financial modeling knowledge, but coupled with some visualizations. And nowadays, it's one of the popular data science area is what we call data storytelling, right? Because data scientists are more technical people, so they are not good at delivering a story. So if you are good at that visualization, storytelling, and maybe a little bit of descriptive analytics, you can play that role. So there are a lot of opportunities available, especially in freelancing. Online platforms, Fiverr, Upwork, and TopTal. If you are looking as a consultant level, then of course you can get it.
All right, and the next question is what is data lake under data science?
Yes, so data lake, now as I explained, the data warehouse works with structured data. So data warehouse you can use with your transactional SQL databases, right? Data lake is more flexible, more free form sort of a data platform, right? Where you can simply dump, say you have table SQL structured data, you can put SQL into your data lake, right? If you have images, set of images, without converting, without trying to incorporate it into SQL table, you can just dump it as it is. Text, any audio files, video files, anything you want to analyze, doesn't matter what the structure is, web data, HTML pages, right? So you can dump everything into a data lake. So data lake, there are a lot of technical definitions, but think that as a more flexible way of connecting to unstructured data sources, right? So you can connect your structured primary data source within your organization, but at the same time, you can connect to a lot of unstructured data, your website, your emails, right? You can just dump it into your data lake. So there are different technologies, but everything started with Hadoop, right? So if you have heard about Hadoop we consider as a data lake, right? It supports various different data formats, right? So that's the main difference.
All right, and the next question is related to a particular and certain industry, private education industry, and he asks how to incorporate data science and AI into private education college to manage financial crisis. It's
Okay.
how to incorporate data
Yeah.
science and AI to private education colleges.
Yeah. I'm not sure about the financial crisis part, but in general, because I'm also in education, not exactly education, but I prefer to think that as an education industry. So uh, now, in my own experience, uh, I use data science models and especially AI related and especially automated technologies to find or shortlist potential students, right? I'm heavily using LinkedIn to filter out uh, or rather list potential, because my product is data science. So I sell data science courses, right? So I don't need everybody to see. I don't want to operate in a mass platform like Facebook or Google Lens. So I want specific platforms like LinkedIn. Even in LinkedIn, I need people who are interested in data science and work and starting their career in data science and data analytics, right? So I have tools and technologies to filter out those potential students and send them kind of customized messages, right? And also keep them in my audience to engage with them, maybe newsletters, maybe through emails. So all these uses sort of automated data science or AI related technologies, right? So if you want to go further, uh, you can create, if you are creating sort of online course delivery platforms, right? That is where you can incorporate a lot of data science and AI models. Especially, you can track the behavior of your students. Say you are offering your, let's say you are planning to launch an accounting or financial modeling course. So if you use an advanced platform or your customized platform, you can upload your videos and you can create kind of a sandbox environment, and you can track your students' behavior, how they answer, how they cover material, what they do, and run through an algorithm. And based on the input, you can customize your content, customize your exercises, customize your activities, right? Customize the quiz that you post. So that is kind of an extreme end. So you can plan into that, but in general, in your uh, sales cycle or in your normal delivery, also you can incorporate a lot of models.
And I'll take the last question. And he asks, what are the sources of unstructured data available for different industries? For example, people sell through Facebook ads. What data available for those sellers?
Right.
Unstructured.
So as I told you, like there are more unstructured data than structured data. So uh, there are a lot of innovative unstructured data sources that we can find out, right? So the go-to topic is actually social media, because you have a lot of content there. You have posts, you have likes and dislikes, you have reviews, you have ratings, right? But there are a lot more, say for an example, weather data. Weather data, you can get like satellite images, you can get it like through an web API, which you can incorporate into your sales forecast sometimes depending on your industry, right? Say for an example, your product is seasonal, or say you are selling umbrellas, right? So definitely the rainfall and the weather data you can directly incorporate into your forecasting models, right? Or it could be some simple web-related data you extract from maybe from the central bank or some macroeconomic data, right? So there are a number of unstructured data, not only social media, right? But social media, you can do a lot. But nowadays, with all the data privacy laws and all, there are a lot of restrictions. So a lot of providers have restricts giving away free information, but you can do web scraping. So there are a number of different unstructured data. So if you are asking for a specific industry, I can, maybe help it out. Maybe you can contact me, send me an email. I'll be happy to name few.
All right. Thanks a lot, Mr. Thisara. I have two more questions. I'll keep it for the next session. That concludes our first session, and this is a gentle reminder to all our participants for this webinar to participate in the next session, which is on 1st October, Kuwait time, 4 p.m. to 6 p.m. So thanks a lot, Mr. Thisara, and the participants all over the globe. Thank you so much. Have a good evening.
Thank you. Thank you all.